Okay, today we're going to start lesson 31. We're going to talk about polygons. Now, what polygon is just a figure that has a particular number of sides. Um, we have we know that anything with three sides we call a triangle. Four-sided figure uh, we call a quadrilateral. And there are particular names for the different polygons based upon the number of sides. So what I'm going to do is I'm going to make a little list here, number of sides and the name of the polygon. So if it's got three sides, it's a triangle. And four sides, it's a quadrilateral. Most of you probably know most of these already. If it's got five sides, it's called a pentagon. Six sides, it's called a hexagon. Seven sides, oops, I don't know why I did that. Seven sides, it's called a heptagon. Eight side, we probably already know that's called an octagon. Nine sides is called a nonagon. 10 sides is called the decagon. And then there are some others. There's 12, it's called a dodecagon. Dodecagon. Okay? And there's names for 11 and 13 and so on. You can look those up if you're so interested. There's what we call those when we have that type of a thing. So if I wanted you to name a polygon that looked like that, you just count how many sides. 1, 2, 3, 4, 5, 6, 7, 8. So since that's got 8 sides, it's called an octagon. Okay? Now, what a polygon is it's a figure who each of its sides is made up of a line segment. Okay? There has to be an inside and an outside to the polygon. You can't have it be like that. That's not a polygon because there's not an inside and an outside. There's a whole bunch of little places. So this is not a polygon. Okay? All right, so then we're going to talk about what's called a regular polygon. So what a regular polygon is a polygon that has all sides equal and all angles equal. Okay? And so you look at something like this up here, and there's no way that this angle can be the same as this angle right here. So this can't be a regular polygon if it goes back inside like that. That's called a concave polygon. So an example would be if I had like a hexagon. A regular hexagon is one where all of the sides are the same length and all of the angles are congruent. This angle is congruent to this one's, congruent to this one's, congruent to this one, congruent to that one is congruent to that one. Okay? So we have what are called interior angles. That's what these are. Interior angles. And if you were to extend a side out, this angle right here is called an exterior angle. Okay? To find the sum of the interior angles, of a regular polygon, there's a formula. The sum is equal to n minus 2, where n is the number of sides of the polygon, times 180. Okay? So for instance, we know that there's 180 degrees in a triangle. Triangle has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. If we look at a quadrilateral, it's got 4 sides. 4 minus 2 is 2. 2 times 180 is 360 degrees. So inside a quadrilateral, every quadrilateral, there's 360 degrees. Okay? Now these again are regular polygons, so that's what we're working on. And so you're going to have some problems that they're going to give you an example. Let's take a look at one like this. Well, I don't know. Let's look at this one right here. We want to find the sum, interior angle sum. So we want to know what all of these angles add up to. Okay, so it's a matter of counting how many sides this has. And so I just go through and label them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. So that's got 11 sides. My formula to find the interior angles is n minus 2 times 180. So now n is, this is n. So 11 minus 2 times 180, which is 9 times 180. And you just take your calculator and you just go 9 times 180. And it equals 60 and 120 degrees. So that's what all of these angles add up to inside of that figure. All right? So you'll have some problems that ask you to do that. It's just a matter of counting how many sides, plugging it in that formula, and out comes your answer. Okay? Excuse me. So now with these, it says find the measure of one interior angle in each regular polygon. Round your answer to the nearest tenth if necessary. So if I were to do this one, I know there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is called a decagon. It's got 10 sides. Okay, so I know that there's 10, n equals 10. So what I do is find what all of these add up to. The sum is going to be 10 minus 2 times 180, which is 8 times 180, which equals 8 times 180, 1,440. So the sum of all these angles adds up to this. All I need to do then is there are 10 different angles. So I'm going to divide this by 10. So in interior angle, each interior angle is going to be 1,440 divided by how many sides there are. So this comes out to 144 degrees. Each one of these angles right here is 144 degrees. And that's how you find an interior angle. Find what the sum is, divide it by how many sides there are. Okay? And the last one is we're going to find what the measure of an exterior angle is. Now for that, there's a simple formula for that too. An exterior angle is equal to 360 divided by the number of sides. There's our formula we're going to use. Okay? We could find what an interior angle is and then subtract it from 180, but that's way too much work. This is a whole lot easier. So all I do is count how many sides. 1, 2, 3, 4, 5, 6. 6 sides. So this each exterior angle right here is going to equal 360 divided by 6, which is 60 degrees. So this is 60 degrees. If I draw one here, this is 60 degrees. Because what you're doing is you're going all the way around the circle. And there's 360 degrees in a circle. divided by how many angles there are. And that's how you find an exterior angle. And that's what your assignment is on today.